Okay, our goal here is to solve linear systems by graphing. This is one of the methods that we can use given two linear equations. We can solve them by graphing on a coordinate plane. The first thing you'd want to do is you want to take each equation and write them separately, side by side. The goal for that is now we can get each equation ready so we can solve them for y, and what we want to do is we want to get them into the slope-intercept form, which is y equals mx plus b, where m is the slope, b is the y-intercept. First thing we'll do here is, if you notice, you've got y kind of all by itself. That's nice because this is only one step problem now for us to get to solve for y. So the first thing we're going to do is we're going to subtract 2x to both the left and the right side. Once you subtract 2x, the positive and negative 2x add up to 0, and we end up with y equals, and here over on the right side we have two terms that are not common terms. We cannot add them together, so I like to take and put the x first, so negative 2x plus 9. And what we have now is we have an equation that is in the form of y equals mx plus b. I like to go ahead and take my slope, which is the m, and turn that into a fraction. That's going to help us later on when we look at graphing the equation. So if we start here, to indicate the slope is negative 2 over 1. And the y-intercept, put that down here, is the positive 9. Alright, once we know the slope and the y-intercept of a linear equation, we can go ahead and create a graph. So what I'll do is come over here, I'm going to grab my graph, and the first thing we need to do is we need to go ahead and plot these points. How do we plot a point? Well, the first thing that you need to do is you need to look at your y-intercept. The y-intercept is the b value. That is your starting point on the graph. That tells you where you're going to be located on the y-intercept. Excuse me, on the y-axis. Here's the y-axis. Here's the x-axis. The y-axis always runs straight up and down. The x runs left to right. So start with y-intercept of 9. If you go starting at the origin, we're going to go up positive 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that is our very first point of our graph. That's our starting point. That is called the y-intercept. Now, from that y-intercept, we use the idea of slope. Slope, I think of as a fraction. Rise over run. The rise is how far do we go up or down. The run is how far do we run to the right. So, if you start at the y-intercept, we rise negative 2. That tells us to go down 1, 2. And then the run of positive 1 tells us to move to the right 1. So, rise, negative 2, run 1 to the right. And that pattern will continue. Slope is a pattern. Go down 1, 2, over 1. Go down 1, 2, over 1. And I like to just take the idea of slope and go ahead and plot as many points as you can on your graph. So down 1, 2, over 1. Down 1, 2, over 1. Down 1, 2, over 1. And then continue. Alright. Once you have all your points lined up, you can go ahead and create a nice straight line. I would recommend grabbing a ruler or the side of a notebook and making as straight a line as possible, one that extends the length of your graph. I'm going to scoot this up a little bit. So there is my first equation graphed for us. I'm going to group these really quick. And then we're going to go ahead and graph the other line of our linear system. So we need to get this in the correct form. This has to be in the form of y equals mx plus b as well. Now if you notice, the y actually has a number attached to it. That's going to mean we have to do a couple more steps. But we always deal with our x values. Notice the equation from before. We subtracted 2x. Well, this happens to be a 2x as well. So to move that over to the other side, a positive x and a negative 2x, excuse me, positive 2x and negative 2x, those are going to cancel out. So we're going to subtract 2x to both sides. And when we do that, the 2x is reduced down to 0. And we don't write that on that side. Sometimes people like to cross through it. The 3y is left over. And notice it's a positive 3y because this is a plus. If it was a minus, we would have to sneak a negative in front. Rewriting this now, I like to write the 2x, excuse me, the negative 2x first, and then the plus 15 will follow after that. Again, these are not like terms, so I cannot add them together. Now we're ready to get y all by itself. And this 3 right now is actually attached to the y by multiplication. So to undo, or the inverse operation of multiplication, is division. I like to take and divide every single item by 3, and I purposely write it divide by 3 in this manner. You'll see why in just a second. Now, when we're reducing this, I think of these as fractions. So the fraction 3 over 3, well, 3 over 3 reduces down to 1, or 1y. When writing 1y, we usually just write the y because it's assumed that there is a 1 in front. Let's go to this fraction, negative 2/3. That fraction, negative 2/3, cannot be reduced. So leave it as negative 2/3 x. And then we come to 15/3. 15/3 is a fraction that can be reduced. The numerator and the denominator both divisible by 3. Well, 15 divided by 3 is 5. 3 divided by 3 is 1. So we have 5 over 1. But 5 over 1 is the same as 5. So we just reviewed, we just solved for y. And going back now, we need to determine what is our slope and what is the y-intercept of this equation. The slope is the number that is attached to the x. That is the negative 2/3, which is our rise over our run. And then our y-intercept is the positive 5. That is going to tell us where to start on our graph. So, now that we know what slope and the y-intercept are for this equation, let's use blue. We're going to go ahead and graph. Here's my y-intercept. Remember, the y-intercept is the starting point on the graph. So we're going to go ahead and start at the origin. Move up 5 spots. 1, 2, 3, 4, 5. There is the first point on our line. That's the y-intercept because it crosses the y-axis. Now our slope tells us to rise negative 2 and run 3 to the right. So we're going to start at our y-intercept, and we're going to go down 2. 1, 2, and then we're going to run 3 spots to the right. 1, 2, 3. That is our next spot. And actually, that's a very important spot we'll come up talk about later. Continue that slope. Down 1, 2, over 1, 2, 3. There's the next spot. Go down 1, 2, 3 to the right. And if you look here, we ran out of room on our graph, so we need to go the other direction. To continue this pattern of down 2 over 3, we're going to do the opposite of that. We're going to go up 2 over 1, 2, 3 in this direction. Go up 2 over 1, 2, 3. That's enough for us to get a nice, accurate, straight line. We'll come back up here to our graph, and we're going to connect all those points with a nice straight line. I like to make sure my graph extends the length of the page, or the length of the graph. And then what we're looking for is we're looking for the solution to the linear system. Once we've graphed both lines, the solution is the intersection point of those two lines. That is at this dot right here. That's the point of intersection. This point has a location. We read it. X comes first, so how far do we go over? 1, 2, 3 from the origin. We always start at the middle. So 1, 2, 3 in the positive direction, and up 1, 2, 3 in the direction for y. So our solution is positive 3, 3. And every time you write your solution, x comes first and then y. Let's reverse that. That is the solution to our graph. So by solving the linear system, we plotted both lines, we found the intersection point, and we found our solution of 3, 3.